Hello. See if my mic is in a good spot. So I'm very excited to be here. I've never been to Russia, so thank you to the Go Analytics organizers for inviting me, and Sasha from Yandex for getting me over here and showing me around the town a little bit. So this session is, should digital analysts be more like data scientists? And you can probably guess that I think the answer is yes. So thank you very much. I'm done. No. So what I really want to talk about is why I think digital analysts should become more like data scientists. But before I dive directly into answering that question, I want to go back almost a quarter of a century to October 10th, 1993. The fact that I can say go back to almost a quarter of a century and I'm talking about my own life as an adult is a little depressing. But on October 10th, 1993, I was standing on top of this mountain. And this mountain is called Mount Katahdin. And it is in the northeastern corner of the United States. And I was there because I had just completed this is going to be a 5-month journey. And that journey had actually been on foot. And this clicker is not playing nice with me. There we go. So I'd walked pretty much the eastern seaboard of the United States on what's called the Appalachian Trail. It's 2,142.7 miles long, which I may be running this whole thing from maybe I'll stand over here, which is pretty much the eastern seaboard of the United States. That 2,142.7 miles, for all of you who use a more normal measurement system, I'll do the conversion, is 3,488 kilometers, which is almost exactly the distance if you walked from Barcelona to here. So it's a pretty good long hike. So why am I talking about that? Well, last year I was on a different journey, and it was a very different kind of journey. And it was a journey as a digital analyst. And that journey started back in the fall of 2015. And my goal was that by the end of 2016, I would be a more data science-like digital analyst. So these two journeys are similar in many ways. But one of the big ways they're similar is that, this is going to be interesting, is that they were both very challenging. This is actually considered, this is part of the Appalachian Trail. It's called the hardest mile on the Appalachian Trail because for an entire mile, it is just boulders that you have to scramble over. But like a lot of things that are very challenging, it is also very rewarding. This is not me standing on top of Mount Katahdin. I could not grow that much facial hair if I never shaved again in my life. But why? Why did I take the journey last year? Well, fundamentally, it's because I believe the role of the digital analyst is evolving. And one way to think about, that I like to think about analytics is falling on a spectrum. And on one end of that spectrum, we have basic metrics. How much traffic came to my site? Where did it come from? What was my conversion rate? How was that trending over time? Very quickly, every digital analyst moves into segmentation. That's obviously new versus returning visitors, sure. But also, even if you get up to multi-channel attribution, I would claim that even that is really just an advanced form of segmentation. But if we keep moving along that spectrum, we actually get to the world of data science. And in my experience, digital analysts mostly live on the left 2/3 of this spectrum in the basic metrics and segmentation area. And what's happened over the last 2 to 5 years is that our business stakeholders, the marketers, the product managers, they're getting much more self-service with the basic metrics. So that's partly because they are getting more and more familiar with digital data and comfortable with it. But it's also because the tools are getting better and more accessible. And analysts are getting tired of doing some of that basic metrics stuff, so we're building them spreadsheets where they can do some self-service. So what does that mean for the digital analyst? If we don't have to do as much with the basic metrics, well, one option is that we can just do more of the segmentation work. And that's fine, but what I really think is that's a missed opportunity. What we really could or should do is look towards that data science world, because that can do two things. It can make us much more efficient with what we're doing in kind of this world of segmentation, but it also can help us do things with the data that we haven't done before, that actually adds more value to the organizations we work for. So I keep saying data science, and what is data science? And in some ways, data science is like big data or growth hacking. You ask 20 people, you'll get 20 different answers. As a matter of fact, if you go to the English version of the Wikipedia page, it has this introduction that says, data science employs tools and techniques and theories drawn from many fields within the broad areas of, and then it lists over 20 different areas. And every one of those is a link to its own Wikipedia page. So I did spend a brief period of time where I thought I was going to become a data scientist. And then as I dug into it, I realized I wasn't. I'm not that smart, and I'm not that young. But I think what we can do is look to what data science is and pull aspects of it into our work as digital analysts or marketing analysts. And I don't think it really matters which areas you pull in. I think it varies based on your role in the organization and what you're trying to do. I'm only going to talk about two areas specifically today. One is, I was standing over here to hope that it would. One is computer programming, which I think is kind of foundational to data science, programming with data. The other area is statistics, actually applying statistical concepts and modeling to our data, which turns out to be a little trickier than maybe we would hope. So computer programming. So to be clear, that's what I'm talking about, text-based scripted programming. It's like the Microsoft, the Excel Visual Basic macro editor, right? It's text-based. This is not a graphical user interface where you're dragging and dropping things. It's kind of like JavaScript, except with the programming with JavaScript, that's programming to capture the data. And we spend all our time talking about Google Tag Manager and jQuery. That's programming too. It's a script-based language, but that's for getting the data. Whereas what we're talking about now is programming with the data after we already have it. And one kind of thing to note is that programming with data is a lot like boiling water. It's a lot like boiling water if you're trying to push this analogy to the Appalachian Trail. Because if you're hiking and you're doing long distance hiking, you need to boil water efficiently. And back in 1993, the way that almost everyone who was hiking the trail did that was using one of two stoves. One was called a Peak 1, and one was called an MSR Whisper Light. I was carrying the Whisper Light. They looked very different, but they had the exact same function, just boil water efficiently. And in the world of programming with data, we have something very similar. We have R, Python, and R. And with the stoves, as it turned out, it's always something technical. Come on, back up one more. As it turns out, when you have one of those scenarios, there usually isn't one that's just better. Neither one of those stoves was better. They both had their pros and cons, and neither Python nor R is necessarily better. They actually have more similarities than differences. They are both programming languages. Python is technically a general purpose programming language, whereas R is a programming language of, for, and by the analyst. But they're both programming languages. They both are open source. which means you don't have to get your manager's approval to go spend money on a software license. You can download them, install them, and not have to pay anything. And they're kind of part of the open source world where the whole community is extending them. They both are supported by enormous communities. It is very hard to run into a problem and have a question and go looking online and not find that that question has already been asked and answered in Stack Overflow or in some other site. Most importantly, apparently Siri is now responding to me. Siri wants to weigh in. And they're both connectable to digital analytics and other data sources, to a MySQL database, to Google Sheets, you name it. So they both can connect directly to APIs. So I am going to talk about R today. I know there was an R and R Studio session earlier. I am kind of on the R train as well. But that's not because I think R is necessarily better than Python. I think either one is a fine platform. It's just I can only learn one at a time. So we'll hop back to the Appalachian Trail briefly. This is Clingman's Dome. It is the highest geographic point on the Appalachian Trail. It's in the Great Smoky Mountains. And as it turns out, it's where I was during my undergraduate commencement ceremony. I left school a little bit early to start hiking the trail. I still graduated, I just didn't do the fancy walk across the stage stuff. But that was kind of a point when I had completed my education. And education, any form of education, is arming us with power, the power of knowledge. Be it a university degree, be it attending a conference, reading blog posts. Well, programming with data is very, very powerful too. And it's powerful in a couple of ways. I may just give up and just talk. I'll just do this as interpretive dance instead of the slides. So one way that it's powerful is just as a data extraction tool. So when you're hooking directly into an API, you have a lot more flexibility over what data you pull and how you pull it. And I've met plenty of analysts who have started going down the path of R or Python, and that's really all they're using it for. And that's fine. They are becoming much more efficient with what they are doing with data. As an example, I've had several Google Analytics 360 clients over the years, and in my case, every client I've had has had multiple websites, and they wind up with each website has its own Google Analytics property, and then a view, kind of a main view for it. And so occasionally, I'd get asked for a basic metric. Hey, for this website, can you tell me how many sessions we had last month? Sure, I can. I can log in, I can pull that. And then occasionally the question would come, well, how does that compare to all of our other sites? Well, that's kind of a tedious thing to get to with the Google Analytics web interface. I can go to the overview report, and then I can set the date range, and then I can click through each view and record that number. It doesn't take too long. It's tedious. It's not particularly painful, but if I have to do it again and again and again, it really would get pretty annoying. It's living in the basic metrics land. Well, if I decide that I'm going to hook into the API and write a program, a script, in 17 lines of code, and I'm not counting the comment lines or the blank lines or where I put carriage returns to make it more readable. There's 17 commands in this. I can actually query 38 Google Analytics views, and that's 38 different calls to their API, and it takes all of about 19 seconds. And what that script generates is really just a comma-delimited file that is one row for each view. So it looks a lot like a Google Analytics export, but it's actually every row is a different view within Google Analytics. But that works. I could take this and I could then, in Excel, I could chart it or do whatever I wanted. So that sets me up for the next time somebody asks the question, or a similar question, or asks for a different time frame, well, now I've got something in addition to my flexibility of extracting the data, in that I've got something that is reusable and extensible. So in my example, it's reusable in that this was for one of my clients. I was going to show this at a conference. Shouldn't have client information up there. Well, this is the only thing that I had to blur out to kind of hide what part of who the actual client was. So because it's text-based, you've got these blocks of text that you can copy and paste much more easily than trying to take an Excel file and rip out the named ranges or pivot tables or other references to kind of reuse an Excel file for something else. But I can also extend it. So same client, totally different question, was across those different sites. Well, this is what the original script gave me. Across the same sites, what is the breakdown of paid traffic versus non-paid traffic? A simple segment using channel grouping, default channel grouping, to define non-paid traffic and paid traffic. And I wanted to crank through, in this case, just the top 18 sites. So I modified the code. I started applying segments. I was pulling 3 pieces of data rather than 1 for each site. And I said, I don't want to just push this into a text file. I actually want to visualize it. So I can extend it to actually include a visualization. But it was just building on what I had already done. Another example that I think it's a little bit more fun is, am I going to agree with you? Okay, is a heat map. And I love looking at metrics across 2 dimensions. When somebody says, how much traffic came from, I want it by device category. Oh, and I want it by last touch channel. And I usually think, don't you want to see those together? So I can do a 2-dimensional view and get this nice heat map and get a visual view of where really are the hot spots for any one metric. And I can now easily swap this out for any metric, and I can change my 2 dimensions. And I can do these other things, which are showing some weird anomaly counts. Same basic visualization, same pulling data, but doing different operations on it. We'll come back to this in a minute. I could extend that a little farther. Ooh. Now we're going to try the live demo. And build something. Come on. Use that same heat map idea, but give myself a little bit more control to actually control the dimensions. So what this is doing, I'll move out of the way, is it's querying Google Analytics on the fly right now. They have a fast API. And I've got my 2 dimensions. I've selected what metric I want to use. And then at the bottom, because I don't want to have some random spike in the data give me a misinterpretation here, I've got that same grid, but with sparklines. Now, this is obviously a US-based site, so that's really not that helpful to see country. But what if I did want to look at my channel grouping against device category? Come on, internet. So now I have that, and I can build in some simple little controls to say maybe I only want to see the top 4 channels. Well, let me change and give myself that control. So that's kind of neat. I've got a way I like to look at data. I can now reuse this and easily add multiple things to it. Well, this is Google Analytics. In the States, Google Analytics and Adobe Analytics are the 2 main tools. But I was coming to Russia, and it's Google Analytics and Yandex Metrica. So I was like, can I reuse this and do the same thing with Yandex data? And now I have limited sites that have Yandex Metrica installed, so this is my podcast site, so they are not large numbers. But it's the exact same interface with the exact same, I didn't have to rewrite any of that code, and now it's pulling data from Yandex Metrica, which, as I was going back and forth with Sasha, she said, you should have first touch and last touch. And the one, that was just to give someone the option, but I was like, oh, this is a neat way to look at whether first touch and last touch are that much different. For this tiny little site, not so much. But that's a big thing for me that I could take and build something once, and then I can use it with a wide range of data because I just have to change the inputs and not do that much on what I'm doing with it. Okay, so I don't have to use my slides because it worked. So, and there are links at the end to both of those demos if you want to play around with them yourselves. So that's programming with data. The next area is statistics. This is like a game. I can say it, and then you guys can guess when the slides catch up what the animation is actually going to be. So statistics is something that to me is kind of scary. What are you thinking? Hold it up? It's too late to fix. So it's kind of a scary topic. If you ask me to define a p-value, it just depends on when you ask me whether or not I happen to remember right now what a p-value is. Or as a web analyst, how often for myself or a lot of the analysts I work with, I'll say, when was the last time that we actually ran a correlation? What about a regression? Okay, I'll just build all these. What about, keep hitting. Are we comfortable with what a confidence level is? How that differs from confidence intervals? Do we have a good way for objectively detecting outliers? When is this an outlier that is noise that we should just discard? When is this an outlier that we really should look into? Do we think about false positives and false negatives? What about this getting on up there, somewhat advanced Bayesian versus frequentist approaches to analytical problems? So this stuff, it turns out, is kind of hard. And for those of us who didn't start out in statistics, there's a lot to learn. It's part of the journey I'm still on. But, you know, things that are hard often are things that are worth the effort. So I'm going to give two quick examples of how I've sort of started to do stuff with statistics that I hadn't done with data before. This is a choreogram. And the way we read it, this is a year's worth of data. I may just finish presenting over here. So the way we read it is we've got 365 days of daily data, and each dot on this scatter plot is the x-axis is the number of sessions from video, and the y-axis is the number of sessions from display. It makes a scatter plot. And then in the bottom, we actually get the R value, which has nothing to do with the R programming language. So I did this early in 2016, and it's one line of R code to generate the choreogram. Maybe a dozen lines of code to actually get the data to generate it. And I can configure it within that. I would never put this in front of a business user. That would scare them. But to me, I thought this is something I could generate very, very quickly. And it kind of opened my eyes to these are things that I was not able to readily do in Excel. In this case, my strongest correlation, it happened to be the same agency managed video and display. So when they were spending money, they were spending it on display and video, and when they weren't, and therefore they wound up correlating. So not particularly actionable or insightful. The other example is something that has really only been the last 4 or 5 months that I've gotten it working and understood it. But this has been a question, something that's bugged me for 15 years. And that is, every time you have a KPI, you want some context. Am I way long? Are you waving your hands like I'm long? Am I over? What? We good? Okay. So when you have a KPI, we always want some context. How did it compare to target? How did it compare to the previous year or the previous period? And generally, a lot of times, we want to see a little trend line. And as a business user, often, when they see that trend line, they will look at it and say, oh, the metric went down. And the first question they ask is, why? Why did the metric go down? Analyst, please tell me why the metric went down. And this is the wrong question to ask first. And I've known this for 15 years. This is not the right question. The first question we better ask is, did the metric move enough for me to care? The metrics are always going to change, go up or down. But how much is too much? Or how much is enough that we need to actually care about it? No, really? That button works. So forecasting, it turns out, can help answer this question. Now, up until a few months ago, I always thought of forecasting as being about the future. So if I have data through yesterday, then forecasting is definitionally about today and forward. But that's not what we want to do here. That's not the application of forecasting for this. If instead we pretend that yesterday was a couple of days ago, and if we're good at pretending, then that means we don't actually know what the last 2 days' data are. With that, we can now use this data to build a forecast, and one that's very common to use is called Holt Winters, and it's a very slick. It's not that hard to understand. It's time series decomposition, but I can build a forecast based on that data. This is much richer than just putting a trend line from Excel onto something. Because I'm building it with a real methodology, I can also put a prediction interval on it. So a 95% prediction interval, that's like a confidence interval, because I am providing a forecast, but I know my forecast will not be perfect, so I'm going to provide a range and say I would expect, all things staying the same, 95% of the time, the actual value will fall within that range. Now I can come back and put my actual data on it, and I can say, you know what, 2 days ago, the metric went down, but not enough for me to care. Yesterday, it actually dropped outside my prediction interval. Maybe I should look into this, because that should only happen 5% of the time. Putting this into practice, this looks something like this. And I actually do this for a client that I provide a weekly report. They get weekly totals, but separately, I look at daily data for the week, and then I count, or I have the system count, how many days of the week did the result fall above the 95% interval, prediction interval, and how many days did it fall below? This actually I don't really need other than to understand what those two numbers are. So now I can very rigorously, this is going to get back to what we saw earlier, is actually get counts across all these dimensions and very quickly assess, were there any particular channels or customer segments that moved significantly during the week. The flip side, another way to look at this is all based on, I didn't really expect anything to change, but I want to find if stuff did change. The other way, another way to use this same idea is with, I made a change. I launched a campaign, I redesigned a landing page, and I'm going to do the same thing. I'm going to take here's where I made the change. I want to take the data leading up to that to build a forecast with the prediction interval. And now I want to look at my actual results, and I'm going to count anything that falls outside of that prediction interval as being a change that was caused, an impact, the result of the change that I made. So that's not using Holt Winters. This is actually a tool that a guy named Mark Edmondson wrote. You can go to that URL, and if you provide your Google Analytics credentials, you can actually play around with this with your data. So that's kind of about all I can cover in a short session, but if you're ready to put this kind of data science thing to practice, I have 2 resources I can recommend. Both are a little more R-oriented than Python. One is the Measure Slack team. How many people, or anybody in the Measure Slack? Okay. Everybody at this conference should be a member of the Measure Slack team. It is like the Measure hashtag on Twitter, except organized and with no spam. So it's free to join. But if you specifically care about this topic, there is an R and statistics channel that is a great little community within that to participate in. everybody from really advanced users to beginners. The second resource is dartistics.com. This is a website that Mark Edmondson and I built that is really for learning R and statistics from a digital analyst perspective. So it starts with the very basics and gets more advanced. It's actually, the website is built with R, which is kind of neat, and we're continuing to grow it. We've got a bunch of additional statistics-oriented stuff that we are working on adding. And with that, those are all the links to things that I showed. I am apparently very, very accessible, so you can find me many, many ways. And I have to plug my podcast, the Digital Analytics Power Hour, a bi-weekly podcast for analytics geeks. And with that, I think we have time for questions. Спасибо. Is that good?
Спасибо.
Okay.
Yeah, you pronounced it right way. So, who has any questions? Пожалуйста, не стесняйтесь, вы можете задавать их на русском. Okay.
Hello, thank you for the presentation. I would like to understand how could you, can you go back to the slide with the correlation dots, with dots and this scheme?
You just wanted to watch me try to advance multiple slides. Really? That one.
This one. Can you please explain how could you understand from this diagram when the correlation, when there is a correlation, actually? I mean, these dots means sessions, or what does it mean?
Yeah, so the dots are sessions, and this is a case with, I mean, if you took any of these and made them a big scatter plot, you'd see it a little better, but that's why putting the R value, you know, the bigger the number, the stronger the correlation. So it's another, like I looked at this and also saw that really weekends tend to be very different. If I really wanted to push this farther, I'd want to pull the weekend data out. So this is a pretty busy one. If it was, you know, 4 or 5 channels, they'd be a little bigger, it would be a little more visible. But that's why I say never put this in front of it looks like a Rorschach test in some ways. But I mean, you can see, once you know that this is a stronger one, you can sort of see that there is a little bit of a relationship there, but it's hard to tell how it differs from these other ones.
Thank you.
So.
Thank you very much. Could you tell me why you use the prediction interval for forecasting? I thought that the prediction interval are useful for describing the current data, but not for forecasting.
So this is where I'm still on the journey on the statistics front, because I was actually calling it a confidence interval, and then I had somebody who is very knowledgeable say, no, in this case, with this Holt Winters, you're using your prediction interval. So I cannot.
I'm the same. I don't understand that.
Yeah, so I said my goal was to be more like a data scientist by the end of 2016. It's a journey that is continuing. I've gotten much more capable with R.
Thank you very much.
Okay.